Okay, so let's talk about the reaction rate investigation that you'll be doing at home. So the point of the investigation is to see how one factor affects the rate of chemical reaction. We've modified the normal investigation so that you can do it at home, so you'll be using the chemical reaction that happens when you place Alka-Seltzer tablets in water. Now that chemical equation has been shared with you previously from some of the earlier documents, so you can find that in Google Classroom. But mainly, inside of the Alka-Seltzer tablet, there is some acid. It's generally in the form of citric acid, and it reacts with something called sodium bicarbonate, and that produces a number of things, including, most important for us, CO2 gas. So mainly we think of this reaction as the reaction between acid and the bicarbonate that's in there, the sodium bicarbonate, and it produces carbon dioxide gas. Now you're going to have three choices of independent variables for you to vary. You can adjust the temperature, the concentration, or the surface area. Those are sort of three of the classic collision theory factors that affect reaction rate. So those are going to be your three choices. When I get into the method, there are going to be some limitations on that. So let me try to stop myself, and I'll wait and I'll explain it when we get there. Your dependent variable is going to be the rate of the reaction, and coming up with a quantitative way to actually measure and calculate the rate of reaction, and then getting average rate of reaction values so that hopefully in the end you can get a quantitative relationship between your independent variable and the rate of this particular chemical reaction. So what I mean by that is you're not just going to say when I increase temperature, it makes the rate go up. You're going to try to actually figure out, is that a linear relationship? Is it an exponential relationship? Directly proportional relationship? There are different kinds of relationships, and hopefully your data will help reveal that. And you'll be able to make a statement about, oh, well, for every 1 degree I warm up the reaction, the rate goes this much faster. So that's what we're looking for in the end, a more specific answer than just it increases or decreases the rate. And of course, anytime you're doing an investigation like this, you're also going to need to outline the control variables, why they need to be controlled, and how you're going to do that. Okay, so by now, hopefully you've got Alka-Seltzer tablets at home. I'm sure you have access to water. Depending if you choose concentration as your factor, you're going to be using white vinegar to adjust the acid concentration. Other equipment that you probably have at home, something to measure temperature in your kitchen, a ruler if you're doing surface area, stopwatches for measuring time of the reaction. A stove is probably the best option in terms of warming things up, changing the temperature. Also, I suppose a freezer and a fridge in terms of cooling things down. You've got ice as well. Hopefully, no, maybe not, but your kitchen may have a digital balance which can measure how heavy things are. And I imagine that it will have some volume measuring devices. Those could be as simple as measuring cups. So you could use that to control volumes. You may have more advanced measuring cups that have milliliter markings on them. That would be even better. Okay, so part of what you're going to do before your next synchronous class is you're going to be trying out your method and figuring out what equipment you have available to you in your home. Most of the equipment you're going to want is probably in your kitchen. Okay. Also, when you think about your method, consider the total amounts of available materials. Generally speaking, we want you to do 5 independent variable values. So that would mean like 5 temperatures or 5 concentrations, and a minimum of 3 repeated trials. So you're looking at least 15 trials, plus you're probably going to make some mistakes, and you're going to do these practice trials before next class. So think about the amount of Alka-Seltzer tablets you have, and plan accordingly. Don't mess around too much. If you use up all of your tablets before you really start your data collection, then you're going to have to wait to order more. So you're looking at 15 plus trials. Obviously, this is a minimum. You are welcome to test more than 5 independent variable values, and you are encouraged to do more than 3 repeats to strengthen your results. Another limitation is if you do choose temperature, we're going to ask that you don't go above 50 degrees Celsius, because above 50 degrees Celsius presents a pretty serious burn risk in terms of how hot that water is. So I would say treat 50 degrees Celsius as your upper limit in terms of temperature. If you are going to choose one of the other factors like concentration or surface area, then there's some more information here that's going to be relevant to you. In terms of concentration, you can't really change concentration by using more of the tablets in the same container. I know that on the outset that might seem like it's valid, but when you add more tablets, you're actually changing a lot of different factors at once. You're changing surface area as well as concentration, as well as just the amounts of materials. And I think that we're not going to allow that as a method for changing concentration. Concentration is really a variable that is limited to talking about solutions and the concentrations of things in a solution, so dissolved in the water. And so for us, we really care about the concentration of acid. And so if you want to adjust the concentration of acid, you're going to need to use the vinegar to do that. Now, the acid in vinegar is a little bit different than the acid that's in the tablet, but for our purposes, that doesn't really make a difference. It does the same reaction as the acid that's in the Alka-Seltzer tablets. So if you want to have a more concentrated form of acid and you want to have that be your factor that you investigate, then we can have a meeting where we talk about how to adjust the concentration of vinegar. So you would have the starting concentration of vinegar is about 5% acid, and by adding different amounts of water, you can dilute that concentration down and have 5 different concentrations prepared and see how that affects the reaction rate. So it does involve this equation. It's actually fairly straightforward and simple if that's one of the factors that people want to investigate. Obviously, temperature, picking 5 different temperatures and achieving those temperatures is probably the most intuitive of the different variable choices, using your stove, fridge, freezer, some combination therein. I think people understand how to vary temperature. Surface area pertains really to solids. So we're talking about the surface area of the tablet itself. This right here is an image and equation information about calculating the surface area of the tablet. You have to look at the 2 faces as well as the side, which is you can treat sort of like a wrapped up rectangle. And obviously the way that you adjust surface area is by breaking the tablet into smaller pieces. But as you do that, you're going to have to keep track of the overall total surface area. Because remember, as you make the pieces smaller, so as the piece size goes down, the total surface area goes up, which is somewhat counterintuitive. But if you use the same amount, so if you use 1 tablet, if you break it down into smaller pieces, you will be exposing more surface area. So this one has a little bit more calculation involved. It's maybe a little bit more of a challenging one from that perspective, but it's not really any more challenging to actually carry out once you do it. It's just in the preparation. So we've got 3 different factors. You can change the temperature of the water, you can change the concentration of acid that's in the water by using vinegar, or you can change the surface area of the tablet itself by breaking it into smaller pieces. The details of how you're going to vary that is up to you. So that's why that's your independent variable. You're going to decide on the method. The dependent variable is about measuring the rate of reaction, and I'm going to talk about that after I look at the timeline. So this timeline is specific to my A4C1 class. We've just lost a day due to the snow day, but that's okay. So we've already done the looking at the Criterion B example and the marking. I'm going to share a video where I go through my marking of that sample. So now this is the day that we're missing with the snow day. We would have just gone over the exemplar and we would have done this talk that I'm doing right now with the video. So you're not really going to fall far behind. But I need to make sure you know what to do for your next asynchronous class. So in the asynchronous class, you are supposed to carry out practice trials. So using Alka-Seltzer, using the equipment that's in your kitchen, just making sure you're comfortable mixing the things. That's pretty easy. You put the tablet in water, but also measuring time, calculating reaction rate, calculating average, and calculating uncertainty. So your asynchronous assignment is to repeat 3 trials under the same conditions so that you can go through a full set of practice calculations. and you're going to submit your work on Google Classroom before Friday's class to show me that you've done that, and to highlight if you have any questions. You'll know what those questions are before Friday. Okay, so that's your asynchronous work. I'll go through a sample calculation at the end here. Synchronous work on that Friday is we're going to check in together. I'm going to answer questions, and I'll make sure that that you know what's expected of you. Any time that's left on Friday after you've asked your questions is for writing your Criterion B. The following asynchronous class on the 16th, a Tuesday, will be for writing the Criterion B. You also have a weekend in between those two. And then finally, your Criterion B report, your plan, will be due on the 18th before the Crocus break. You'll then have time to collect data on that day, and you'll collect some data after the break. I can do some check-ins in between that if needed to help answer questions and guide people. But the idea is you really need to try out your method this week. Practice doing the calculations to make sure you know how you're going to carry this lab out. That's really the only way that you can write a proper Criterion B where you actually outline a detailed method. You really have to have tried it in order to actually write about it. So the practice trials this week will help you do a general sense, and then you'll have to do some more trials where you actually vary your independent variable. So try out, how am I going to get these different temperatures, these different surface areas, etc. I think you're really going to need to try them out before you can write up the method that's going to be due on Thursday, February 18th. We've already seen the B. This talks about the Criterion C. So Criterion C has not happened yet. Criterion C is going to happen after break. That's where you do the processing and the conclusion. Okay. In terms of the actual data processing, remember that in order to calculate a rate, if we use the hot dog example, whenever you calculate a rate, it's always per time. So you're always dividing by the time it takes for something to happen. In the hot dog example, 72 hot dogs being eaten in 12 minutes is a rate of 6 hot dogs per minute. You take the amount and you divide it by the time, and so then you get this rate. So for us, we're looking at the time it takes to dissolve a tablet. So if we take the amount that's dissolving, which is 1 tablet, and we divide it by the time that it takes to do that, then if I use an example, if it took 20 seconds to dissolve the tablet completely, then I have 1 tablet divided by 20 seconds gives me 0.05 tablets per second. So this ends up being my value for rate. Now, tablet isn't really an official scientific unit, so we probably present the rate as just 0.05 per seconds. I know that's a bit of an odd unit, but it means how much of the tablet is being dissolved or reacted every second. So 0.05 tablets is being dissolved every second. So that's how you calculate it. There are other options for calculating the rate, so you'll get to choose what makes the most sense for you. If you do have a decent digital balance at home, you can put the reaction, this is my drawing of a reaction, you can put that reaction on the digital balance, because as the tablet fizzes and as it releases gas, the mass of the overall container is going to drop. So as the mass goes down, that's how you know the reaction is happening. That kind of gives you 2 options. One, you can time how long it takes for a certain mass change to happen. So maybe your mass change you're looking for is 0.1 grams. So instead of waiting for the whole tablet to dissolve, you could sit there with your stopwatch, put it on the balance, and time how long it takes for a certain amount of mass to disappear. So then you could calculate the rate this way. The mass change, 0.01 grams, or 0.1 grams, divided by the time it took. And so your rate would be in terms of grams per second. So you'd have a different unit for rate, but a totally valid way of expressing the rate of the reaction. The third and final option is probably the most intensive. If you measure the mass every couple of seconds, we did this with a volume of gas being produced, but you can also measure the mass as it goes down every couple of seconds. And if you record that data, it will allow you to make a graph. And if you get the slope of that graph, as we did in class, the slope of a trend line on that graph is equivalent to the rate. So that's the third way I can think of to get the rate of this reaction. Definitely the most intensive. It will involve the most data. But if you like the trend line method where you fit a trend line to your data points and the slope of that trend line is the rate, that's also an option. So different methods, the total time it takes for the tablet to dissolve, the time it takes for a certain amount of mass to drop, or looking continuously at how much the mass is going down and getting the rate from that. So what you've got to do for your asynchronous lesson is collect 3 trials of raw data. Now these aren't really going to count for your lab report, they're really just practice, just to make sure you know what equipment is available in your kitchen and how to do the calculations. So in terms of raw data, you should have 3 trials that you're going to collect. So I'm imagining everyone's just going to do this with room temperature water. So I've said 22 degrees Celsius, and this is the time for the tablet to dissolve. So I've just listed it as time in seconds. Trials 1, 2, and 3. So these are the 3 different values I got. So again, do this handwritten or type it up. If you do it handwritten, you can take a picture to share it with me. Then in terms of sample calculations, just to show you, so a sample calculation, here's the equation, rate equals 1 divided by time. That's what we said, the tablet, 1 tablet per this many seconds. Then if this were my actual lab report, I've outlined which trial I'm using to do the sample calculation. So I'm using the room temperature trial number 1. So I took the 20 seconds, which is from that trial, and I'm doing the rate is 1 over time. So rate is 1 divided by 20 seconds, and I get my rate of reaction is 0.05 seconds. Then I'm going to do a second sample calculation, which is the average. When you do an average, you have to add up all the different trials and divide it by the number of trials. So these 3 values are the 3 different rate values. So I went ahead and I calculated them already. They're down here in this table, trials 1, 2, and 3. Just doing that 1 divided by time method, I got 3 different values for rate. So here's my average sample calculation. I add up those 3 values, I divide by 3, and I get the average rate of the reaction is 0.043 tablets per second. Final thing you have to calculate is the uncertainty. The uncertainty is a way of expressing how much variation there was in the trials. And the way we do that is with the method that's called half the range method. So I take the highest value that I got and I take the lowest value that I got. The highest value I got is the 0.05 as my rate, and the lowest was the 0.038. So I find the difference between them by subtracting, so 0.012, and I divide that by 2. That's why it's half, so I'm half in the range. So the uncertainty is 0.006, same unit as the rate, so per seconds. So my final process data table is shown here for this treatment of 22 degrees Celsius. I have the 3 different rate values because I processed all of those, 1 divided by time. This is the average, 0.043 seconds, and here is the uncertainty of 0.006 seconds. So in your asynchronous class this week, you're supposed to try to carry out 3 trials of reactions, measure the time it takes, however you decide what you're looking for time. You're going to get 3 calculated rate values, you're going to calculate an average, and you're going to calculate an uncertainty, and hopefully that will clear things up for you, or if it doesn't, you'll at least know what questions you have to ask. Eventually, once you get all your different data recorded, you're going to make a graph of your independent variable values and your rate of reaction values. You're going to have error bars on them, and you're going to add a trend line to those values with an equation so that you can answer your research question of what is the relationship between your independent variable and your rate of reaction. And you'll be looking for the slope there for seeing the relationship. Okay, sorry for the long video. I hope that has clarified what I expect of you for your asynchronous class, which is to collect this data, show the sample calculations. You can do it handwritten like I've done here and then take pictures of it to submit it. And you should also have decided and thought about how you're measuring the rates and what your independent variable is going to be. Are you going to choose concentration, surface area, or temperature? And you should make that clear in your submission before Friday's synchronous class.